All right, so it sounds like a lot of people here have at least some experience with coding or like are still at the beginner level, but that's pretty much perfect because that's who we're, again, aiming this lesson for. So to start off, well, this is an R lesson. You may have noticed that the title is called Reproducible Science in RStudio. I think the keyword to focus in there that we're going to be talking a lot about today is reproducible. And something that, I mean, we in the science community should be thinking more about always, but it's easy to kind of let it go by the wayside, is keeping our work reproducible, keeping our work documented. This is important for many reasons, obviously just because science in general should be reproducible, so that other people can build off of your work. But also it's important in contexts such as if you're working with collaborators, say, on a project. It's important that if you send your code over, for instance, or people are repurposing your code, that they can make sense of it. But even more so, the kind of unspoken fact that your most frequent collaborators often future you. A lot of the times you'll find yourself going back to work you did maybe 3 months ago, 6 months ago, a year ago. And I've definitely had this experience of looking back and being like, why didn't I write what I was doing here? Like, this is just a bunch of meaningless code. So it's worth keeping in mind that you're collaborating with future you as well. So at least for that person's sake, it's worth trying to make your work somewhat reproducible. So fortunately for us, RStudio, or the folks at RStudio, kind of recognize this as a growing need, and R being as popular as it is in the scientific community, I think this was a very good thing for them to do. And to that end, they've added this new feature called R projects. And today we'll be doing some R stuff, but we'll primarily be working with the lens of these projects and seeing what kind of features they offer. So the structure of this lesson is we're first going to have a quick overview of RStudio, kind of what all these various tidbits of it are. And then we'll be starting a new project, working through an example workflow with some example data. So just doing some relatively simple kind of looking at a data set, kind of filtering it out a little bit, filtering out a few things, and then making a few plots. But along the way, we'll learn about how to organize our workspace, how to keep things organized in RStudio, and then how to kind of tap into certain other external features of RStudio that have been added in since, that can help us make our projects kind of more reproducible and organized. So to begin with, I think an important thing to go over if you're starting out with R, especially because this wasn't clear to me when I started, was what is the difference between R and RStudio? So R is actually a programming language independent of RStudio. RStudio just happens to be a really popular program used to interact with R. The technical term for what RStudio is an IDE. So you may have seen that being thrown around. IDE stands for Integrated Development Environment. That sounds really fancy, but it's really essentially just a program that allows you to program in R, but has a bunch of extra bells and whistles that make that easier. So at its core, R is just a language, and that brings us to this first pane over here. So it's on the top right of my screen, but it's likely that in your RStudio, this is in the bottom left. It should look like, it should have like a little kind of, what's the word? Yeah, an arrow. I don't know why I wanted to say glowing cursor. It's not glowing, it's blinking. It should have a blinking cursor. This is essentially where you would type in R code. We'll be doing a lot more of this later on, but if you just want to give it a quick whirl, you can type in 2 + 2. Sorry, Francis, I stole your thunder with this one.
I was about to say that. Yeah.
But this is where you could directly give commands to R. We'll be doing a lot more of that in Francis' section of the lesson. Sorry, to quickly step out of the lesson for a second. I know the lesson says 6 to 8, but we do anticipate finishing around 7:30. The idea is we'd like to have a bit of time for discussion, networking, snacks, whatever you guys would like.
And I was just gonna plug in, like, raise your hand if you have any issues. Like, I'll be circulating if you have anything. So don't wait until the end when you're like swamped. Just let me know and I'll have it.
Yeah. Cool. So yeah, so this is where we'd actually be typing in R code, but oddly enough, I'll say this right now, for most of this lesson, and I'd say for most of your kind of R career, you won't find yourself using the console that much. This is mostly for directly kind of testing code, but primarily we'll be using a pane that we can't even see yet. So let's head over to this button over here on the top left. It's like a little page with a plus. If you don't see it, another way to get to it is just going to File and then New File. So if you head over to New File and click RScript, this will open a whole new pane. Did that work for everybody? So either this button or the New File dialog, either one of them will lead to the same thing. You should see this sort of pane open up, another blinking cursor. This here is called the source pane. This is what we'll be working in for pretty much most of this lesson. The source pane is essentially just a text editor at its core, and you can write R scripts in it, you could write plain text in it. You can write documents that are a mix of both, as we'll see in short order. But just as a quick kind of demonstration, if you click on this little box down here that says RScript, these are the various kinds of text files you can write in here. And there's a ton. There's JavaScript, C. I can't guarantee that all of those are maybe best suited to RStudio, but what I'm trying to get to here is this is just a text editor. The thing about the source panel is we're often going to be writing code in here and then using a shortcut, which we'll get into, to just send that code to the console where RStudio will evaluate it. So this way we don't have to keep clicking back and forth. We can just write a bunch of code here and then run it. So these are the two main panes of RStudio, as they're called. These two other ones we'll be worrying about less, but are still useful to know about. This one is called the environment pane. So again, on your screen, this is probably on the top right. I've moved them around a little bit. The environment pane just has a bit of useful information. Later, we're going to be learning about how to create objects. And once you do that, those are listed in the environment pane. In history, we can see any code we've run. So I've got a lot of leftover code from stuff I was doing earlier. Yours will probably look empty, save for 2+2. And the connections, we pretty much don't have to worry about. That's for people who work with databases and stuff. So since I'm not going to be using this that much, I can actually minimize this pane. I'm going to use this little button over here to minimize it. And so I have a bit more room for my source panel. The final thing that we're going to look at is this sort of miscellaneous panel on the bottom right. So by default, this shows a file tree. So it's a series of files. On Macs, this is your home directory. I'm not sure what it is on Windows, but this can be changed. And then there's a few other useful tabs. There's plots. So if we make plots, which we will soon enough, those will show up here. A listing of packages, which are kind of further add-ons for your coding. Also something we'll get into. One of my favorite panes, the help pane, where you can actually look up the documentation for any function. So instead of having to Google what a given function does, you can look it up right here from RStudio, which is really nice. And then viewer, which is kind of a catch-all for a host of other things. So I'm going to switch this back to files. Are there any questions so far before we get started? Cool. So that was pretty much a tour of RStudio. But the thing that I mentioned earlier, projects, we haven't really talked about yet. And that's up here in the top right corner. It ought to say project none on your screen. It's kind of obscured on my screen by some numbers, but so you can see that. So if you click on this drop down, I get a bunch of existing projects, but the key button up here is new project. All right. And what we're going to do is create a new project and then work within that for the rest of the lesson. And this is just like a general R tip. I've only started doing this much more recently, but it's made my life a lot easier. If you're working on a given project, it's best to create a new project for it and segment it in that way. Because a project is going to, and we'll go into the various things creating a project does, but in essence, it'll kind of keep everything related to that project in one place, which is going to be really important for that project, but also eventually as you get multiple projects and need to keep things separate. So let's click on new project. It's going to say, do you want to save the current workspace? We're going to say don't save because we didn't really do anything besides remind ourselves that 2+2 is 4. So once you click don't save, this dialog should show up. Is there anyone who doesn't see that? Awesome. Okay. So we have 3 options. One is that we can start a project in a brand new working directory. This is what we're going to do. But just real quick, you can associate a project with an existing folder. So if you're already worked on something and you've got a folder with a bunch of data files and scripts and stuff, all is not lost. You can still make a project out of that folder. The final thing is version control. And this is a bit more advanced, something we're going to keep touching on throughout the lesson. But version control, how do I put this? Services, I suppose, allow you to basically track all the changes that are happening in a folder at a given time, which is really useful for documenting your code and keeping it reproducible because then the entire history of the file is available to you. So if you happen to have a folder on one of these version control services, so GitHub is probably the most popular one if you've heard that, you could actually turn that into a project. But we're not going to do that. We're going to click on new directory. And there's a ton of different projects you can make. You can make websites. You can make web apps. You can make packages. But we're just going to, oh, I misclicked, sorry. We're just going to go with new project. And for the most part, you're going to want to go with new project if you're doing anything that's not one of these specific things listed here. We're going to click on new project and give it a name. So in our case, we could call it coders-demo. You could call it something else if you'd like. Banana llama, I don't know. But do make sure to not have spaces in it. I believe if you put in a space, it still inserts a dash or something. I'm not sure about that, but it's best to just avoid that altogether. The next thing asks us where we want to create this project. I've got a folder called R on my desktop. You could save it in documents or wherever else. Obviously, that could also be moved around later on. It's just something to keep in mind. Now, these last two things over here, I anticipate most people won't see the checkbox that says use packrad. But do people see the box that says create a Git repository? No. Is there anyone who does see it? Okay. So we have two people. Okay, that's fine. So these two show up if you have Git and packrad installed. And both of these are kind of convoluted to install. I mean, not necessarily, but if this was a Git lesson, we'd have you install it, whereas we've already had you install RStudio in like 5 packages. So it's fine if you don't see it. We're going to be touching on these things. We're not going to be delving into them. But these are the two of the add-ons that I talked about that help make your project more reproducible. I'm going to check off create a Git repository. It's not going to substantially affect how this lesson is going to go, but it's going to add a few things that are worth just kind of knowing about. So I'm going to click create project. It's going to say switching to project, and then RStudio is just going to like apparently restart itself. And if you actually check, it's created a basically new window, and the old one's gone. So projects are like essentially new instances of RStudio, which also I believe means you can't have multiple projects open at a given time.
You can.
You can?
That's the way of having multiple RStudio windows open.
How?
I've had multiple projects open. Can you try opening one right now?
Let's try it. Let's demo this right now at Coders. Well, there's recent projects that open project in new session.
Yeah.
I just learned something.
That's the only way that I found to be able to have two RStudios working.
Oh, no way.
But it gets really confusing because you forget what's in your environment. Yeah.
Oh, right.
Yeah.
Yeah, I would generally avoid doing that, but that's good to know. I take that back, and I just learned something. Just for some context, everyone here at Coders, like the instructors, the execs, pretty much none of us are like formally trained computer scientists. We're all scientists of other sorts who've like taken up programming as part of our work. So if you feel kind of intimidated in that sense, please don't, because we're all learning as well.
Like I started grad school with no experience of coding any language whatsoever.
That was pretty close. Anyhow, so now that we're in this project, the first thing to notice on the top right, it should say Coders Demo. And the panes mostly look the same, but a few things have changed. So let's look at this files pane first. You should see nothing but this Coders Demo file. If you had Git on your computer, you should see git ignore as well, but otherwise it's this rproj file that you should see. This is a new directory. You can see the file path for it over here. So mine is desktop coding R Coders Demo. So this is, it still lives on your computer, same as any other folder, but R sees it slightly differently. Now this rproj file is kind of useful to know about. You won't find yourself interacting with it that much, but it kind of does a lot of useful things in the background for projects. So first, it tells R where the root of this project is, and that's going to be important in a bit when we're organizing this directory. Certain packages, it's also in their interest to know where the root of your project is in trying to find, say, data files and whatnot. So they'll use this file as reference. And finally, if you actually open this folder up in Finder or Document Explorer or whatever your OS has and click on this rproj file, it'll specifically open RStudio to this project. So it's also a handy shortcut. The git ignore file is, if you have Git enabled, git ignore is a file used in Git, so Git being a version control software, where you kind of list files that you don't want Git to track. That's, again, not super relevant, but it's just so you know what that file is, basically. So if we look at our history, that's empty. Look at our environment, that's empty. The 2+2 thing didn't even happen. Everything that happens in this project stays in this project, essentially. So the last thing to mention is if you have Git enabled, you should see a new Git tab show up in the environment pane. I'm going to be touching on this at the end of the lesson. But again, if you don't have Git installed, that probably won't show up, and that's fine. Okay. Any questions so far? Awesome. So the first thing to do with any given project, and I feel like a lot of people don't think about this. I definitely did not think about this in my first year of grad school. And frankly, looking back at that folder, it's a travesty. It's really messy. And with the gift of hindsight, I've learned that getting a consistent directory structure set up from the get-go is extremely important. We're going to be going with like one type of directory structure, but you may prefer something else. So don't feel like you have to adhere to what we do here. But this is just going to be like one kind of example of how to go about this. So we're going to use this new folder dialog here to create 3 separate folders. And the structure we're going to see is fairly common, but again, you're welcome to create your own spin on it. I'm going to click New Folder, And we're going to create a folder called analysis. You might also want to call this scripts or something because this is where that kind of thing will go. So type in analysis and press enter. And note as well that R will make that folder in here. Even though we just typed in analysis, we didn't go desktop/coding/R, That's kind of the point of a project is you're just in this folder. We're going to create another folder called data. So click new folder, type data, hit enter. And then the final one is going to be called plots. Now, the idea behind this structure, and again, there's multiple ways to go about this, is the data folder will just contain, as the name implies, data. But an important caveat to that is this data folder should be considered read-only. You should be able to write new files to it, but you should never edit any file within data. So even if you have a raw data file within data and you filter out a few things, that should be saved as a new data set. So data should be seen as this kind of read-only folder that just accumulates data files, whether they're subsetted versions of existing data files. But data is basically something you never actually enter, like by clicking on and opening a file and like manually editing. This is really important for reproducibility's sake and also to not drive yourself insane over time if you change something in your data and forget about it. Because if you do open up a data file, for instance, and pull it up in Excel and you're like, oh man, I totally misentered that value, that should be, all of these should be incremented by 5. I would say it's actually a better idea to save that to a new file. Because it's very likely you'll have some line of code somewhere that refers to that version of the file and relies on it not being changed. So this is why it's really important to not edit your data files, because it might cause things to break later on. The analysis folder is going to contain scripts. So it can also contain other things. So in my case, my analysis folders tend to contain like a digital lab notebook or just like a log of what I did on a given day, or of like non-R commands I ran for whatever reason. So this can be done however you'd like, of course. I've known people who've split their analysis folder into scripts and logs and that sort of thing. Totally up to you. Same goes for data. You can split up your data folder into raw data and filtered data. But the important thing is to be consistent and make sure the names make sense. And this sounds kind of dull, but like it is so important to have this stuff laid out from the start because it creates a consistent framework for you to do your science in. And it also means you'll always know where to look for something. Finally, the plots folder, as its name kind of suggests, is where plots will go. This doesn't have to be a separate folder. It could be within analysis. But personally, I like having my plots separate, especially because often perhaps you'll be doing a bit of exploratory data work and you'll be making lots of temporary plots. And if you keep those in the same folder as, say, your data or your analysis folder, that might get cluttered. So it's helpful to have all those image files in a different plots folder. Again, totally up to your discretion, but this is the suggested structure we'll be working with today. So with that, I'm going to hand over to Francis for a bit, and we're going to work through a quick example workflow. We're going to be using a few packages for data wrangling. Sorry, I'll start moving. A few packages for data wrangling, but given the time constraints of the lesson, we're not going to be going super in depth in them, just enough to like do some basic stuff. But if you are interested in getting more or knowing more about those packages, I'll be providing links to more material about those after the lesson.
We'll see you soon.
Take it away.
Okay. So now I'm going to just take us through an example workflow and some good practices for working with that within an actual R Markdown document. So now that we have the folder and the project created, we still need something to work with. So similar to how we made a script last time, you can do this plus button over here or the new drop-down menu or drop-down menu for like new file. We're going to be working with an R Markdown right now. An R Markdown and an R Notebook are very similar structures. It kind of comes down to, like I prefer Markdown. You won't see much of a noticeable difference between them really. So we're going to launch a new Markdown. We'll call this maybe like intro R. Let's just give a title to it. I'll pretend that I'm Ahmed. It's okay. Yeah. And it gives a little bit of a base structure for it, which is a little bit redundant. So again, I don't really need the environment. I'm just going to minimize this right now so I have more space to work with in my script here. The first thing that I want to do is, even though we gave a title to our document, it hasn't actually been saved anywhere within the actual computers that you're working with. So the save button here, or you can do file save. And I'm going to navigate. Coding. Our coders demo. So I'm going to put this in the analysis folder. And then I'm just going to call this intro R. And when I press save, you'll see that now the file has been renamed intro R with the extension type of an R Markdown. And if you've used just plain Markdown text, you'll find that what we use within an R Markdown file is very similar to how we would format text within a Markdown file itself. And we can peek inside here as well in the analysis folder within the files. You can see that that new file is also populated here. So this is just a file explorer for what we have locally. Within these 3 little dashes, and so you can see there's a bit of text that's bracketed by 3 dashes. This is your YAML header. It's more of like a global setting for the document and how it gets compiled. So we're not going to touch that in this lesson. And here there's some base, but we're just going to delete all that and start fresh.
Sorry, then press X and then press I.
Yeah, okay.
Sorry,
I got it. So now we're working with a fresh page. So here, anything that you type will be considered plain text. So you can say like, this is R. And it's not code. It's not going to be interpreted by our exact, here. It's outside of our window. Even if we wanted to press run, it's not, oh, okay, you can't actually force it to run. But it's not really interpreted as code until we put it into a code chunk. So when we start using R, we'll put this insert R, and this will insert a code chunk. A code chunk is bracketed by these 3 little tildes. And then within the curly brackets, it denotes a language. So you could add a code chunk for HTML or Java or even Python within an ARC Markdown file, but generally you're going to just be using R. And it's a good practice to keep outside here notes about what you're doing in each of these code chunks and break up code chunks according to what you're logically doing. So first we're going to read in libraries. And libraries are kind of the applications that we use within R to do different functions. And the way I like to explain it is they're kind of like the applications of your phone. So when you first download if we have an application you want to use, the first thing you do is download it. So we need to install the packages once, but every time you want to use the application, you also have to open it on your phone. And that's using the library command to bring it forward in your session. So every time you want to use it, you still have to run the library function per session, but you don't have to install it every time. So hopefully you guys have already done that. If you haven't, you can do install packages, open bracket, and then quotations because we're interpreting it as a string, not an object, tidyverse. If you've already done this, you don't have to run this because it would take a little bit to get everything in. Within a code chunk, if you don't want to run it, but you just want to keep the code there for kind of like hoarder purposes, you can hashtag it out. So now I won't accidentally run it again. And this is also useful if I want to keep notes. So now that I have everything installed, I'm going to read it in with library tidyverse. So in order to run a line within a code chunk, you can do Control or Command Enter. No?
Oh, I think it's just enter my computer. I'm sorry.
Okay, that's fine. It should be Control Enter in yours, I'm pretty sure.
Or Command Enter.
Yeah, but if you want, you can also use a click button up here with the Run button. And we'll load in everything else. Library, what do we have here? Library knitter, library plotly. So when we have multiple lines of code that you want to run at once, you can either highlight them all and then Control Enter it, or press this little play button. So each of the code chunks should have a play button associated with it. And if you press that, that again will run everything. Sometimes when you're getting started with Markdown files, it's easy to kind of forget to close the code chunk by putting these 3 tildes. Or sometimes if you're just editing and you accidentally edit it, and I find that this causes a lot of problems for beginners. And if you do that, your subsequent code chunks will not have the play button. So if you can't see the play button in your code chunk, scroll up until you can find one that has it and work back from there to see if there's any errors. Okay. So first of all, wait, what is this one? Oops. Okay, I'll just insert like this. Other than R being a very overpowered calculator, we can do some pretty fun things with it as well. So I'm just going to take some notes up here. R can store values in objects. So we're going to be creating some objects. Simply, my mind works pretty simply, so my object names are not that interesting. But if we're going to start a big number, you don't have to copy the exact number. Just put a bigger value, and then small number.
So that's a less than and then a dash.
Yes, so this arrow is a less than and then the dash. It's also referred to as a put arrow because we're putting the value of 23 into the object named small number. So if we run this, we'll see in the environment tab down here that we have two objects. They're both numeric objects with a length of 1. And if we recall them, we can also then do big number. And it returns the value that we stored within it. And objects are also helpful because you can act on them. So for example, if we want to do big number divided by small number, we can run that and it'll do a computation for us. This might seem overly trivial with the example that we have here, but it's actually really nice because it keeps your code consistent. If you want to keep doing a formula that's a little bit more complicated than just x divided by y, you can store the formula like this and just keep changing the values of big number and small number so that things are done consistently without having to copy and paste, kind of like how you manipulate the numbers itself. Other than doing single objects, we can also use vectors. So I'll insert a new code chunk here. We can have numeric vectors. So numeric values are what we've been working with right now. Vector. So after the put arrow, I have C open bracket. So within the language of R, round brackets are commonly denoting functions. So this is kind of like a really simple function, but C stands for concatenate. So when we're looking at multiple values, not just a single number, we use C to wrap up the values that we want to put together. So for example, 3, 1, 4, and 5. If we store that in num vector, then if I run all of this, then I stored these 5 values into the object num vector and then return the values that is stored in num vector. And here it displays the results.
Can I interrupt for a second? So if you've coded in other languages and not R, this is something that's, I would say, relatively unique to R. Any object is in fact vectorized. So you may think of that if you've coded in other languages before and be like, oh, that's like a list, but it's not. Lists are actually different in R. So a vector actually is just that, what we see over there, R thinks of it the same way as it did big number. Because in R, all objects are technically vectors. That's like the one quirk of R. If it sees you save one value to an object, it's like, oh, this is a vector with one number in it. It doesn't affect us in our day-to-day work, but it's nice to know that you can store multiple values in the same object without it being a list necessarily, which is a totally different thing in most other languages.
And R interprets lists kind of complicatedly.
Yeah, lists are totally different
Yeah.
than R. I also very use them.
They're not the funnest to play with. Yeah.
Oh, I'm getting an error when I try to run. It says like num vector not valid.
Okay. So that's probably because that object hasn't been created yet.
Run the first line.
I tried running this one. So.
Okay, I'm gonna let them troubleshoot. So other than numeric values, we can also store character values. So we're gonna make a second one called character vector. And we'll put this is it pi or pi. So you'll notice that when we're working with a character vector, we've grouped everything that we want in a single value within quotations. And that allows R to interpret that this is a character string versus this, which is an object. So if we didn't put quotations and we just did is, it would try to find an object named is to put into the character vector. But if we want to just put the value of these two letters, I and S, then it needs to be wrapped up in a quotation. So then if I highlight these two and run those, then you'll see this is what it returns. And similarly, what I want to show you as well is that you can, for example, if I combine this with a space and run that, you can see we can store multiple words within a single value of a character vector. But I'm just going to control that. And we're going to keep it with 5 values. I'll run it again. And then the last type that we have is logical vector. And a logical vector is only using true or false. So again, we need C to concatenate multiple values together. So you see before I add the last value of E, the text is black. And then once I add E, the syntax highlighting recognizes that it's a different type of value, and it turns it into blue to let it know that this is a recognized unique value. So it's not in quotations because we don't want R to recognize the 5 characters as a character string, but to actually recognize it as a value of true versus false. So we can do false, false. But instead of always writing the full 5 letters out, you can actually just do T or F as a shorthand. So again, I'll highlight these ones. And you'll see that even though I denoted this one as shorthand F, it returns out as a full letter of false. Okay, does that make sense? Is there any questions? So R can also handle multiple, like it's called a mixed vector. If we try to jam multiple, either like numeric, logical, and character into a single vector, what it will do is then coerce it into the most basic one that it can reduce to. So commonly it'll get reduced to characters. But this has been like one-dimensional data, quite simple. The fun is when we start to get a little bit more complex. So we're going to be moving on to 2D data types. The most basic type is a matrix. So for this, I'm pretty much only working with matrix if I'm using like raw genomic data, which is only numbers. But commonly in R, I will be using data frames the most because it accommodates multiple different vectors within its data structure. So let's make a data frame. Here, I will insert a new code chunk, and then we'll have data frame, put arrow. You can build it up from the ground with separate values, but what I'm going to do is just string together. We're going to use a function data.frame to then string together the 3 vectors that we already made. Numeric vector. Oh, sorry, I completed that. So when you're starting to type numeric vector, you can see that it's predicting that I have an object named numeric vector in my environment, and it's kind of asking, do you want this? So when you get to this point, you can either press enter or tab to complete it. It's really useful when you start to have a lot of different objects in your environment and you can't really remember particularly which one it is, but it can be a little bit deceiving as well. So I try to not do it as much, but I fall into bad habits. So we're going to string together numerical vector, character vector, and then the logical vector. And then let's print out the output of that too. And we'll run this whole chunk. So now you'll see here, we have a single object that embeds all of our data. So we have our numerical vector is our first column, our character vector is our second column, and our logical vector is our third column. This is awesome. And you can see here that Tidyverse is really nice, or RStudio is really good about telling you what kind of data structure you're holding on to as well. So underneath the numerical vector, it's telling us it's a double. So double is a type of numerical vector. Under character vector, it's telling us it's a factor. So factor stores a little bit more information than just random strings. And then the last one is called logical. So if you want a little bit more information about the data frame that you're using, you can do structure. So str data frame. I like this command. I use it a lot. So it tells me that the object I fed into it has a structure of a data frame. Excuse me. There's 5 observations, 3 different variables. And then each of the $ signs tells me about a new column. So it's telling me the first column, which title is numerical vector, is numerical, and these are some of the values. The second column, named character vector, is a factor, and there's 5 levels. These are the different options that they have. So structure tells me a lot of information, and this is how I get a quick summary over big data types when they're in a data frame structure. You can also do summary. But sometimes it's not as interpretable depending on what kind of data you're putting in there. But it's nice that it actually gives you some statistics on basic numbers if that's what you're inputting in. Okay, I might need some help. How do I get to the URL? Do you have just in the Chrome?
Pull up Firefox.
Firefox?
Yeah, I should have the issue open there.
This one?
Wait, no, it might be Chrome. Sorry.
Oh, okay. No.
Did I really close that tab?
Okay, sorry. I'll do it. Yeah.
So this might be a good time to open up.
GitHub.com/UofTcoders.
It's on the board over there. GitHub.com/UofTcoders /events with a capital E. I don't know how much that matters. /issues/280.
Okay, so once you get to this website, there is a link to data in the comments.
And just copy that to your clipboard.
Yeah.
So just right click and then copy link.
Copy link location, right?
Yeah.
Okay.
So let's wait for everyone to do that. Anyone having trouble finding the link?
Okay. So I found this really cool data set. Well, personally, I find it really cool. It's a little bit nerdy, but it's a tabulation of different Nobel winners in the past and statistics kind of about metadata about them. So when I'm starting like a new section within my art Markdown, it also is really nice about formatting. So in order to add a header, very simply, you can just do hashtag outside of a code chunk and then Nobel data set. And then I just add a little bit about what kind of I'm working with, metadata about Nobel winners. And the first thing I'm going to do is load in data. And then I'll add a code chunk underneath. So now that we have our new code chunk, I'm going to create a new object and read everything in from the URL that we just copied. So I'm going to call the object Nobel. We'll use our put arrow. One of the tidyverse packages that we brought in is called readr. And as the name suggests, it's really good for reading in different data types. And to specify a package within the readr package, you use the double colons and then the actual function itself that we're going to call up, which is read_CSV. CSV is a data type. It stands for comma separated values rather than a text file, which is normally separated by tabs. So we'll open bracket, and this tells R that we're starting a function. And within here, we simply just need to paste within quotation marks the URL that we just copied from the website. So if we paste that, R does return some base information. I guess we don't really need the console very much because Markdown runs as a self-sufficient document linking up the code and the output. So underneath, you'll see that it returns a little bit of information. So all of these are the different columns within the data set, and it gives a little bit of information about the data type. So prize year is double, which is a numerical data type, and category comes in as a character. If we want to take a look at this new data type that we're going to be working with, we'll add in a new code chunk. We can do head of Nobel. Tidyverse, admittedly, is actually really good. Like, even if you forget to do head, it will only print you out the beginning of it.
So real quick, is there anyone who had trouble loading the data set?
Awesome. So I'm going to minimize this environment tab. You can see here that it's telling me I'm only printing out the first 6 rows because of the head. I'm only looking at the head of the data. And it's currently displaying columns 1 to 3 out of the 18 columns. You can scroll with these little arrows over here as well to look through the different data types. The Markdown gives a really nice output to make it easy to interpret the data that you have. But for example, I'm going to print out in the console here, if we do head Nobel, it's like really raw, and Tidyverse with a tibble will clip it so that it only shows you the amount of columns that will fit in the current window that you have. So it's showing me these 4 columns, and it's telling you that there's 14 more variables that you can see listed down below. So this is something to keep in mind if you're working with scripts in console, whereas working with a Markdown file, you can just interact with it a little bit more directly and look at the data that you have. Okay, so some other things that we can do with our data set when we're just exploring it and getting used to it is call names. The Nobel data set is a little bit complicated, so there are a lot of column names, and this will just return it back as a list, so you can browse for something in particular. For example, you're like, oh, I remember there's a birth cities embedded within it, but I can't remember what the column's called. You can then find it really easily with this function. And as I was saying earlier, summary can be useful. So if I run summary on the Nobel object, but you can tell me, but it returns some silly stuff like its category is a character vector, but it doesn't really give me any information about what is kept within the column of category. So that's why I really prefer working with a structure. And it'll tell me that category is a character vector, and here are some of the values listed within it. It's just a little bit more informative, and I find it's a little bit more robust when I'm working with data types, so I prefer to use structure. Okay, so when we have a data frame a data frame is stringing up many different vectors within different columns. So you can also take out just independent. If you want to collapse these, you can press a little X and it just cleans up your window sometimes. But as I was saying earlier, you can look at individual columns and vectors at a time as well. So Nobel. And another thing that's really good about RStudio with its auto prediction is when I press $ afterwards. So $ after an object is used to denote a certain column. And RStudio will automatically populate all the columns within the object so that you can pick it if you've forgotten which one. So let's look at the prize. And again, I'm just going to print out the head, so the first 6 values of it. So this is me taking out the column prize and looking at it just as if it was a vector. So you can act on the object itself as a 2-dimensional object or on individual columns as a 1-dimensional object. But what I like about R a lot is the plotting. And this is honestly where I spend the most time interacting with R, because it's pretty good for that. And ggplot in particular makes some very nice and reproducible plots. So I believe the pedology of ggplot was also made to make sure that plotting would be more consistent between researchers and applications. And it does a really good job of it, standardizing things like themes. But we'll show you some of the nice features that I really like working with. So we'll insert a new code chunk. And let's start with the function ggplot. We'll open the bracket. And when you open the bracket, again, you can see in the yellow, it's giving you some hints about what is needed within the function. So it's telling you that you're going to have to specify the data. It's telling you that in the mapping, you can specify the AES, which stands for aesthetics. So this is what from the data set am I actually plotting itself, and other things about the environment. So first thing, the data we're going to use is Nobel. And we're going to have to specify some things because it has like, 20 different columns. We can't plot all of them at once. So we're going to specify some aesthetics. And on the x-axis, we're going to put birth date. So ggplot and a lot of the tidyverse functions, and this is something that's kind of unique to tidyverse, is that you can specify column names without needing to do object string. Oh, sorry, that's me. Object string $, object $, column name. Tidyverse knows that X is going to be pointing towards a column that you specified in your data object. So you don't. So if you're working outside of tidyverse, what conventionally you'd have to do is do Nobel $ birth date. But because we're within tidyverse, it knows that we're grabbing a column. And then we also need to specify Y equals category. And if you do this right now, nothing's going to happen because all you did was you gave it data. You haven't really told it how you want to plot the data out. So it returns back an empty plot. We can add a plus sign at the end of it. And ggplot works in layers. So every time you add a plus sign, you're adding a new layer on top. So the first one initiated the plot window. And then next you're going to say, I actually want some points on top. So the geometry of what we're trying to plot is a point. And we don't need to specify anything within this because it takes all of the parameters that you set kind of more globally in the line above it. So now if I run this, point, then I get a lot of points. And from this, it's kind of interesting to see that economics came much later in the game than all the other fields that we have listed here. So we can start exploring data like this. But what if you're like, there must be some other stuff that I can impose on top of this. We can add color. So if you return up into the ggplot line, after your X and the Y, you can add a comma and say color equals, gender. So now when we plot that, it will then recolor each point according to the gender that is specified, so male or female, or not specified. So it's really robust. It's nice because you can actually change the type of the plot quite quickly by changing this command here, so you can explore a lot of different things. I haven't actually tried this, but I think you can just box plot on top of this. Oh, okay, that didn't really work that well. Yeah. So I'm going to change back to point. But yeah, you can change the type of data structure very easily. But let's try making another plot that is also very interesting to look at. So we're going to insert another code chunk below. And similar to before, ggplot, the data, we're still going to be working with Nobel. The aesthetics, we're going to specify x equals the prize underscore year, y equals the birth underscore date, and the color equals category. And again, we're going to specify as a geom point. So that plots us something really colorful. We have a lot of dimension to this data where not unexpectedly, as the prize years progress, the birth dates of the winners also progress. And we can see a lot of different categories here plotted each as a different color. But it's really hard to see the trends, right? You can't really tell how the different categories are moving. So to add a very simple linear fit, we can add another layer on top of this plot. So after geom point, add another plus sign, and then you can do geom smooth. And just to note, within R is very forgiving about your spaces and your enters. So you could have all of this in one line. Personally, I always like to separate it as it's easier for me to kind of organize what I have added onto each of my plots. And when I want to move them around, it's easier for me as well. But it's also just practice, personal preference. As long as you're consistent with it, it's fine. So if I replot it with a geom smooth on top right now, you can see the linear model fits on top. And you can start to see some of the trends. The blue one with the Nobel piece, I guess the winners tend to be a little bit younger until you get up over here. But still, there's a lot going on here that it's difficult to see the trends. So what we're going to do now is segregate it. And this holds all the data for all the different countries. We're going to filter out only the US winners and see if there's any trends in there that we can look at. So we are going to make a new subset. So underneath, insert a new code chunk, Nobel US. We're going to use a tidyverse function called filter. So we're going to filter the data set Nobel. And in this data set, oh, that's kind of weird. I want to filter based on the column of birth country. And within this country of birth, within this column of birth country, I only want to save values that are equal. So notice that there's two equal signs. United States of America. So if you put a single, you've noticed that like earlier on, for example, when we're making this aesthetics, we used a single equal sign. So a single equal sign is a little bit equivalent to your put arrow. You can do x equals 5, and that will store the value of x in the object of 5. Generally, that's a little bit of like an older convention. That's not good practice in today. You should just be using the put arrow for objects, but the equal sign is more for putting a value within a function. Whereas here, when we have the double equal sign, this is equivocating the value itself. So I only want rows where the birth country's value states United States of America. And something we can do to check if this works is dim for dimensions. So we'll print the dimensions of Nobel. We'll filter this into a new object, and then we'll put the dimensions of Nobel US. So if we run this, the dimensions of Nobel will return this. It's a little bit cryptic, but it returns two values. The first value is the rows. The second value is a column. So in the first full data set, we have 969 rows. And then after we filter out for only values that came from the United States of America, then there's only 276. We kept all of the columns with us. You'll find that R is very consistent about when you have the two values, it's rows and then columns. So another thing that's really good, I feel like, about reproducibility in R is copy and paste. Typing everything from fresh is just asking for typos. And this is something that I was really resistant to when I was learning R, to be like, I can type it all, but then it's just a lot simpler. It saves a lot of headaches when you've made enough mistakes that copy and pasting is awesome. So I want to copy this. We're going to make a new plot after. So insert my code chunk. And all I want to change right now is, rather than acting on the Nobel data set, I'm going to change it to the Nobel US. This is another thing about reproducibility in R. Because we haven't changed any of the columns, we can just change the data set and ask it to call back on the same columns. So when we print it now, it's a lot cleaner. Like there's less dots. It's easier for us to see the trends. And you can start to see things that we didn't see with all the different countries. Like the Peace Prize is doing this really kind of weird curve thing with a lot of the younger ones happening earlier on, and then later they kind of get into more older before they win the prize. So these are some fun things to explore the data. Two other nice functions that come from tidyverse, but more in the frame of wrangling, are gather and spread. So we'll insert another code chunk here. We talk about wide and tall data based on the dimensions of the data set itself. So sometimes you have data that's stored a lot vertically, and this is called tall, and then we have stuff that's spread really wide, but I'll show you what I mean. So first of all, I'm just gonna print out the head of Nobel US. And if I'm just gonna navigate to the end, we have information morbidly about like the death. So the city and the country that they come from. And you can see this is very, you can see that, well, you can expect that Oyster Bay, well, maybe not, New York. New York will come up multiple times. So there's been multiple winners from New York and multiple winners from the United States. So we're gonna collapse this and kind of stack it on top of each other. And it might seem a little bit trivial of why we would do this in data wrangling, but a lot of the times you're just wrangling it to fit into the functions that you need to apply it towards, or to get data, or if you're trying to merge, like say example, I surveyed this bunch of students and I'm gonna sample this bunch of students and we need to combine our data together. We need to wrangle it so it has the same column names and the same values stored within it. And you'll find when you're starting to do science, this is what you spend a lot of your time doing. And a lot of the time is you're cleaning up other people's data because they've oriented it in a way that makes sense to them, but doesn't really make sense to you or the applications that you have set up. So to make a tall data set, we're gonna invoke the function gather. First, we're gonna input the data set we're gonna use. So this is the Nobel US. We're gonna create a new column called measure and location. And then what we want to put within these columns is the values in death city to death country. The colon between city and country means I want to grab every column that's between these two column names. They're next to each other, so it's only going to grab those two columns. But if you had more, you could put them further apart and then just add more column names here. So if we run this and head tall data, you see that when I ran the whole chunk, I have two head commands here. So it printed out two data sets. So in this one, this is the original. I'm going to scroll to the end and you can see these are the ones that we acted on. And then the second one, I'll scroll to the new columns that we made. So you can see that we have two columns now named measure and location. So it's measuring the original column of death city and it moved it over to the location column. And just to kind of hammer in what we did to it, if we do the dimensions of Nobel US and the dimensions of tall data, and I'm just going to run those two lines, you can see that the tall data has stacked up the values. You kind of double the rows because you stacked it on top of each other. And sometimes it's just what's necessary for plotting. If you wanted to do the reverse and now you say like the tall data is too repetitive, I want to move it back, we can invoke a function called spread. So wide data spread. We're going to put in the tall data object. What we're going to collapse are the two columns of measure and location. Wide. So I'm going to do head and the dimensions of wide data again. And I'll run just this. So it pretty much will have just undone what we did with our gather function. So now it has separated the values that were in measure and locate and then moved it back to the original format. Okay, so we're going to do, I think, just one more plot that is pretty fun. So ggplot can do some pretty complex plotting. Oh, I'm still within the window, so X that. So I'm going to insert a new code chunk. And then we're going to make one more ggplot. The data equals the Nobel. Oh. Okay, that's okay. We'll just put Nobel, the whole Nobel one. the aesthetics, I'm going to put X equals prize year, Y equals birth date. And let's take a look at the genome plot first. Point. So this doesn't give us a lot of information because all the dots are black. So we can add in our parameter of color equals category. Wait, color equals birth country. And if we print that, eventually. Oh, wait, color. Maybe that's what it's. Hold on. Stop. Is anyone else stuck in the loop? Okay. I don't know if we'll be able. Wait, let me try this first. The legend might just be taking up too much space because I didn't filter it for. Wait, well, actually, just put the US one. Yeah, just put the US one over here. Yeah.
Okay, you can press the red stop button and replace the play button if it's taking too long and move on to other things.
Yeah. So, should I do it? I think I had a filter for the. Oh, here. Well, I'll just add in one more step before it. So let's make a new data set, just Nobel of North America. And we can filter the Nobel data set for birth country. And we use this special function called in. And you're saying within the column birth country, I want to grab everything that has to do with United States of America. Yeah, you should see it change colors because it recognizes it as a special character. Mexico, Canada, and we'll just do those for now. And then here we'll put North America. Sorry, that was a little bit confusing. So now that we've filtered out our data set for not just one country, we put 3, and that's possible using this %. Then when we plot it out here, we replace the Nobel with the 3 North American countries. You can see that it's being colored by the birth country. And if you wanted to add one more layer of complexity, at the end here, you can do shape equals category. And I'll just run this. And you can see that there's a lot of different shapes and information that's being given out. One thing that ggplot is also really good at, and you can actually make your own custom themes as well, is if you add another layer on top, you can do theme underscore. You can see that it has a lot of presets. I like classic. It's pretty nice and minimalistic. And you can see it comes out really clean. So the good thing about saving the parameters that you like for your plot into a single line, such as theme of classic, is that you can reproduce it in multiple plots that you make for the same paper, rather than always specifying your text in the font Arial in size 12 with a grid not there and stuff. You can save it into a simple thing. So when we're invoking something like theme classic, I'm just going to pop in the console over here. If you do theme classic, oh, whoops, yeah. You can see that it actually just has a lot of code stored within it, and these are just specifying a specific parameter. You never really have to go inside and modify it. R is really nice about having everything open source. So if you do like classic theme, but there's like, oh, the font is really small, that's just what I want to change, you can actually modify it yourself, but that's a little bit advanced. So the last thing I wanted to leave you guys with is Plotly. So with an object that's this complex, you want to kind of interact with it to be able to see it more. So we're going to save this into an object called plot. So all I did was before the ggplot, I put in a put arrow, and I'm going to save it into this object called plot. So when I run this, it's not going to generate a plot, but instead I'm going to put it into the ggplotly. I think it's called ggplotly plot. Oh, you can zoom this one, I think. I'm not sure if that's going to be enough for this guy. There you go. You might be able to see it in your window without zooming out, but this is great because you can highlight or you can scroll over it and it'll give you more information about each of the data points. And you can.
Sorry, just because I'm seeing a lot of people with this. If it's smushed in your window, then look for the little open a new window icon.
I'll close this and show it again. So for example, here, it's really smushed. You can't tell anything. There is this. It has like a window with an arrow pointing outside of it. So if you press it, it will pop out into a new window. And you can also use here for like filtering. So you can click on it to be like, actually, I don't want to show any of the points from the United States except for the Peace Prize. And then I'll leave those values over there. And it's scrollable. Everything's really interactive. So ggplotly is really nice when I'm exploring my data. It's hard to kind of like publish or really show this, although I'm seeing a lot more electronic posters. That gives me hope that I can embed something in this my poster and that people will be able to interact with a more complicated figure in my presentations. But especially when I'm exploring it or showing data to a collaborator when you can sit next to them and you can explore the data together rather than having to code out each line of what they want to filter and then generating a new plot. This is a great way to show your data. And it's actually really simple because you don't have to do anything more than just a basic ggplot and then insert that whole thing into a function. Okay, so I think that's going to be like the end of working through an R workflow. Did you want to take it back and do a little bit more?
For sure.
Yeah.
Okay. Were there any questions about that section before we end back off? We covered a lot of little cool things there. So some of the things we looked at, although all of these fall within the tidyverse package that we mentioned, the individual packages are, so the one we use to filter data is called dplyr, which sounds funny, but yeah, so on that same link I have over there, I'll add links after the lesson to more in-depth lessons about that package and also ggplot too. The nice thing about the tidyverse is all these packages are related. They're also made by the same people. So when you type in library tidyverse, they're all loaded in, but they are separate packages and we've got separate lessons on each if you're interested in actually like diving into how these work. So I'm going to close this plotly plot. But yeah, so this was an R workflow and sure, it's kind of like a demo of R in general, but like let's zoom back out to the project side of things and let's pretend this is like a serious analysis you did, right, as part of your project. So I'm going to zoom this back out.
Oh, you might want to do GG save.
Yeah, I'm going to do that right now. So we did a bunch of stuff. Let's now save this file. So use the little floppy icon. Timeless, truly. If you haven't saved it already, then make sure to save it to analysis. And if you accidentally saved it in Coder's demo, then you can go over, you can check off a file. Don't check off the project file, actually. That would be really bad to move. You can check off a file, and then there ought to be a more move setting. So you can move it into analysis if you'd like. But now let's say we did all this cool work. Now we want to save a couple things, the data sets, the filter data sets that we made, and also the plot that we just generated. So we've got Nobel NA right here. Let's save both Nobel NA and then also save the plot that we just made. So I'm going to create a new header called saving our work. Head on down, maybe add a few extra lines. Insert a code chunk. And we're going to use other tidyverse functions to actually write these files. So the same way we used a function called readCSV to read in a CSV, we can use writeCSV to write one in. So since we actually downloaded the file directly, let's actually save that downloaded file to our folder so we don't have to download it every time. Here we're going to type in readr : write_CSV. So like Francis said, we're drawing on the writeCSV function from the readr package, which is part of tidyverse. I know it's a lot, but it is very useful to have these functions because they're quite consistent. So the syntax of this essentially is you first write an object name and then like the object you want to save, and then you write the file name. And this is where another package that we loaded in earlier, way at the top here, this package comes in really handy. It's got a bit of a cryptic name. I'm going to run it again just to be sure, although I'm pretty sure Francis ran the whole thing. But so if you didn't run this already, we could just start it over here, write library here. And what here does is, and run it again, but if you run it, sorry, I'm twitchy that way. If you ran it for the first time, it should likely say path starts at, and then it should list out a folder path. What here is doing is it's looking for this file over here, rproj. And what this allows you to do is basically write file paths always relative to the root of your project directory. And this is important because if I wanted to write, say, Nobel to data, I'd have to write a path that goes back out of the analysis folder, which is where this file is, and then goes into the data folder. And don't write this out, but this is what it would look like. Or you can write it out for reference if you'd like. You'd have to go quote // which is, if you haven't seen this before, it's shorthand for one folder up. Then you'd have to write data. Then you'd have to write Nobel, .csv. And this doesn't look like the worst thing in the world, but as your folders grow more complex, you might find paths that are like // data / whatever. It's terrible to look at. It's not very explicit, and it can really get confusing, especially if you start moving files around, perhaps reorganizing your scripts and such. So this is where the here library specifically exists for this purpose within our projects comes in. I'm going to get rid of the // If you write a file path, but wrap it in the function here, so I'm going to write here right before it, add parentheses, and add a parenthesis at the end. Make sure I have the second parenthesis at the end, kind of the outside one. Notice that R is also pretty nice about highlighting the matching parenthesis. Whereas if I move my cursor back, this one, oh, it's not highlighting, but there we go. This one gets highlighted. So if I wrap a file path in here, no matter where I am within my project folder, it will always read this file path as if I'm in this folder. This is, again, really useful as your projects get more complicated. So it's really kind of handy to have this in your back pocket. So we're going to run this, read our write CSV, and use the here path. And if we peek into data, we'll see that the file's actually been saved there. And we can repeat this process for the other two data sets we generated. Write _CSV, Nobel US, and then here, open bracket, open quote, data, Nobel _US.csv, and so on and so forth. You could save the third one as well, but hopefully you get the idea at this point. Actually, we should do that. Let's do that for completeness. Nobel _NA, here, open quote, data, Nobel _NA CSV. Now, this isn't like an official kind of thing that you necessarily should do, but I like to do it just in case. Whenever I've written a file, I tend to just comment out that line. So adding a hash at the beginning, essentially turning into a note. This prevents me from accidentally, say I had a bunch of other code in this code chunk. If I ran the whole code chunk and accidentally rewrote one of these, having changed it and not wanting to save it, that would be that could be pretty bad. So as a general practice, I like to comment these out when they're done. Again, it's not official practice. You're welcome to not do this, but I found it useful.
I also find that it's actually really helpful as well, because then I can remember where I saved it to.
Oh yeah,
Rather
true.
than deleting it, then sometimes when I'm going back, I'm like, where was that table that I exported it to?
Yeah, it's like a nice little marker of saved things. Now, that's how you save files. How about if we want to save our plot? So for that, we use a function from ggplot called ggsave. And ggsave has a similar kind of syntax where you can write in the name of the plot. So we'll write in plot, and then the second thing would be the file name. It actually specifically asks for the path, but that's essentially the file name with whatever folder stuff is attached. So we'll be using here once again. So plot here, comma, plots slash, and what exactly did we have going on in there? It was birth, I don't know, prize year by birth. And I'm going to save this as a PNG file. You can save it as a JPEG, as a PDF, but PNG seems a good bog standard thing to go with for now. This might break. No, sorry, my mistake. This should be path equals, and this should say plot equals. Sorry about that. So I know this is a bit confusing, plot equals plot, but this is the option, and this is the actual name of the object. And here the option, once again, is path, and then here's what we want to provide it. Is it file name now? All right, sorry, one more correction. File name, not path. I don't remember when that was changed. There we go. So by default, it saves a 7 by 7 inch image. We can actually check other ways of how to save other sizes by typing in the console, although you can do this in Markdown as well, !ggsave. And this will actually pull up the help page for this. And we can scroll down. It's quite extensive, but I think this is probably the most useful thing. Arguments. Arguments is computer speak for options, basically, or parameters. And we can scroll down and see that there are width and height arguments that we can provide it. But let's just say we're fine with 7 by 7 for now. Finally, if we actually go over to Coder's demo, click on plots, now our PNG saved over there. We can even click on this if we'd like. I think it opens it up in preview. Yeah, there it is. Very nice looking. Okay, so we're just a
I just
few.
want to say one more thing.
Yeah.
And I just noticed that our conventions are different for single and double quotations. Ours is very forgiving about that.
Oh yeah. my
Yeah,
bad.
so I just tend to use double quotations. It looks like you tend to use singles. It doesn't really matter for most cases.
Just be consistent. Yeah.
Yeah, there's like a couple things that actually does, but generally either goes.
Yeah, you can use single or double quotes. I use single quotes because apparently pressing shift is too much work. But just make sure that your opening and closing quote are the same kind, of course. Most people just stick to one kind. So I'm going to save this once again. Now let's kind of zoom back out and take stock of our project. So I'm actually going to close this file. You don't have to do this, but we've got this workspace over here. Actually, I'll get to that when we actually wrap up, which we're very close to doing. So a few things to note: if you're someone who's inclined towards doing towards version controlling with Git, which is something I'd recommend, but again, this isn't a Git lesson, so we're not going to go very in depth into that. So in this Git tab, should you have Git installed, basically what this allows you to do is check off certain folders. So say in our case, I wanted to save analysis, so I checked that off. And this allows you to like checkpoint the current stage of this file, which is essentially what Git allows, right? It allows you to, you can think of it as a time capsule, basically. You can save snapshots of what a file looks like at a given point in time. Then later you can make all sorts of edits to it and then save a next, like an updated snapshot. The previous snapshot will still exist, so you can always go back to it. So that's very important for reproducibility purposes. But it also means that you can kind of not worry about losing your stuff because it's inherently being backed up as you go along. The only reason I'm pointing this out is if you're familiar with Git, you can do all of that from here. Also because we initialize this as a Git repository. But again, this isn't a Git lesson. If you are interested in that, we're going to have a Git lesson in a couple weeks, but more on that when the lesson actually ends. So I'm going to uncheck this. And then the last thing I'm going to talk about, as far as reproducibility goes, I didn't have us install this because it's actually pretty unwieldy to install. But it is very useful and worth investing in, especially if you're going to find yourself working in R a lot. And it's something known as packrat. When we saw this at the beginning where it said use packrat with this project, if we didn't check that, which we didn't, but have packrat installed, and I think I'm the only one in the room who does, which is fine, because again, I didn't ask anyone to, you could go into project options, click on that, and then there's a packrat setting. What packrat does is, so far in our project, we've kept our data files independent and our scripts independent, such like they live in this little project folder. Packrat allows you to do the same with entire packages. So earlier we installed stuff like tidyverse and whatnot. Those are like Francis said, it's a phone app that we've installed once and we can always just open it up and call on it whenever. If you actually enable packrat, what it does is it pretends you have no packages. You have to reinstall them, but they're installed specifically in your project. Now, the reason this is really useful is perhaps these packages are often community maintained and they might change over time. So the gather and spread function we talked about today, so the developer of those actually announced that they've introduced this and they're not going to phase out gather and spread yet, but the new versions of those functions are called pivot wide and pivot long. So I imagine like 5 to 10 years will probably get rid of gather and spread. So it's cases like that where it's useful to use something like packrat because not only will that keep your packages separate, it actually saves a snapshot of what that package was like at the time you used it. So if I do a bunch of stuff in this project and install packages with packrat, move on to a different project, 5 years later come back to this, the version of tidyverse in this project is the same as it was 5 years ago, i.e. now. Again, it took me a bit of time to set up packrat. I had some kind of weird bugs with it on my Mac, so which is why I was like, I'm not going to ask people to install this for the lesson because it might get unwieldy. But again, if you get more into R, if you get more into the sort of thing, it's really useful to have that going for your projects. Just it's like an added layer of security. And again, I keep saying it, but reproducibility. You could basically package a project, send it to somebody, and then they could use those exact packages that you used. You don't have to worry about them having different versions of certain packages. Yeah.
And I haven't, this was the first time that I've heard about it when I was chatting with you about this lesson. And that would have saved me from so much misery when I went to publish my work. Because I had to try and track down what version I did my analysis in 2 years ago. I'm pretty sure it was Seurat 1.0. I can't really remember.
No.
So this would have been so nice for me to have that snapshot to refer back to. This session info.
Yeah, I mean, I only learned about it more recently, and even now I'm just kind of like, why didn't I have this before? It is a bit of extra work, of course, like reinstall packages you know you have, but I think the payoff is worth it, and as is the peace of mind. So that's about it for the lesson. Are there any final questions before we pretty much wrap up? Awesome. Okay, so I'm going to chop off the live stream. Thanks everyone for tuning in or watching this. If you did, you can't see me waving, but I did anyways.